Hey guys, this is 3.2 part 3, and in this video we're going to look exclusively at problems that have fractions where you have to clear out the fractions. So I already talked about how to do this in part 1 of the series, but now we're just going to practice this a whole bunch so that you can feel comfortable. So I would say just kind of keep watching this video and trying the examples until you feel comfortable. I've tried to put a lot of them on here for you so that you have plenty to choose from. So to start, just a reminder of the technique. So what you want to do here is you want to choose the LCD of all fractions. So in this case, my LCD is 4. So what you want to do now is you want to multiply every single part of this problem by that LCD of 4. So I'm going to go ahead and let you set that up, and I'll set it up as well. Okay, so now you can see that I've multiplied every single part of this problem by 4. So now what I'm going to do is I'm going to go through and I'm going to basically see how each denominator divides into 4 to see what I'm left with. So starting with this first little cluster here, 4 times 1/2, how many times does 2 go into 4? 2 goes into 4 twice, so now look at what we're left with. I'm left with taking 2 times 1x. This is what I'm left with. So this whole piece here is just going to become 2x. Okay, moving on to the next one. So moving on right here. How many times does 4 go into 4? 4 goes into 4 once. So this is really just going to leave me with, I can write a little multiplication sign if that's helpful. So this will be 1 times 3. So this is going to be plus 3. Now moving on to the next part. This one here. So 4 goes into 4 once. So this is just going to be 1 times 1x. So now I need to subtract off just x, or you could write 1x, whatever you want. And then continuing on, this is kind of a longer one. Now I've got this one here, right? How many times does 2 go into 4? 2 goes into 4 twice. So now I'm going to take 2 times 5. So this becomes plus 10. Okay, now we get to the equal sign. Now for the last part. How many times does 2 go into 4? 2 goes into 4 twice. I don't know what just happened there. And so then this is just going to leave me with 2. So here's the problem that I'm left with. Again, I would much rather deal with this problem than the other one. And so now if I work this out, so I get x plus 13 equals 2. Okay, and now I can just subtract off the 13 and I get x equals negative 11. And so that would be my solution in this case. Okay, so let me give you another one to try now on your own. Hopefully that's a good little refresher for you. So why don't you do this one? Okay, so write this problem down. I will walk you through the steps and tell you when to play and pause. So the first thing that I want you to do after you write this down is determine what the LCD is. Write down the LCD and hit play when you're ready. So in this case, my LCD is 10. So what I want you to do is then write out kind of the action of multiplying 10 by every single part of this problem. Hit play when you're ready. Okay, so I actually went through and did this, and you can see I'm running out of a little space here. But here's the thing I want to point out to you before you go on. Did you multiply 1 by 10? This is part of the problem, right? The rule here is you write every single part of this problem, multiply every part by 10, so that includes this 1. So now, fix that if you need to, and then I want you to go through and divide each denominator into 10, and then see what you're left with. So see kind of what the resulting equation from this is, and hit play when you're ready. Okay, so starting with this first part, 5 goes into 10 twice. So 5 goes into 10 2 times. So this is going to leave me with 2 times 1x. So this first part will be 2x. Continuing on to this part. So 2 goes into 10 5 times. So now I'm left with 5 times 1. So that's going to leave me with plus 5. Moving on to this part here. 10 goes into 10 once. So I take 1 times 3x. That's going to leave me just minus 3x. Make sure you're honoring the sign that was in front of everything. And then continuing on, 5 goes into 10 twice. So this will be plus 2. And now moving on to the other side, 10 times 1 is 10. And then 10 goes into 10 once. So this will become minus x. And then the last part, 10 goes into 10 once. So this will become minus 3. Okay, and now this is something we can totally work with again, right? So from here, you should be able to finish it and hit play when you're ready. So now I get negative x plus 7 equals negative x plus 7. So you might already notice here this is infinite solutions, but if you didn't, you could add x to each side and then the x's would drop out, so you're left with 7 equals 7. And so in the end, that's going to mean that you've got infinite solutions. Okay, so let's try another one now. So I'm actually going to have to use the next page. So let me write one out for you guys. Okay, so we'll do one more problem type like this. So in this one, I'm going to just leave it entirely up to you. So hit pause and then hit play when you're ready to start checking your solution. So in this case, my LCD is going to be, oops, not 10, 15, sorry. So I need to multiply everything by 15. So I'm going to go ahead and write that out. Okay, so I've written everything out, so now let's go through and do all the cancellations here. So starting with the first cluster, so 3 goes into 15 5 times, so this will leave me with 5x. Then 15 times 1 will be 15. Remember, you still got to multiply that 1 by the 15. Continuing on, 5 goes into 15 3 times, so 3 times 1x will leave me with just 3x. And then 5 goes into 15 3 times. 3 times 2 is 6. So this is plus 6. Okay, and now moving on to the side past the equal sign. 5 goes into 15 3 times. So I'm left with 3 times 2x. So this will be 6x. And then finally, I've got 5 goes into 15 3 times. 3 times 1 is 3. So here's what I'm left with in this problem. So now we can keep forging ahead here. So this will become 5x minus 9 equals 6x plus 3. And now I can subtract off the 6x to get 2x minus 9 equals 3. Add the 9 to each side, and I get 2x equals 12. Divide both sides by 2, and I get x equals 6. So that would be my final solution for this one. Okay, so now let's switch gears. We're going to look at another problem type. So now let's take a look at working on some of the other problem types. So now I want to look at this example here. And just notice I left myself a little bit of space because you know you're going to have to multiply by the LCD. So if you want to write this down, just make sure that you maybe give yourself a little space as well. So first things first, I'm going to walk you through this one again with directions. So just looking at the fractions, you might want to think about this for a second. What is the LCD of all the fractions? So in this case, the LCD of all fractions is 10. And so what we talked about is you want to multiply this by each part of the equation. So maybe you want to pause for a second and think about how many parts there are of this equation. So there are 1, 2, and 3 parts of this equation. So what I need to do then is just multiply just each part. So I really just have to multiply each fraction. So I'm going to multiply each fraction by 10. So I'm glad I left myself this room that time. And now what I have to do is divide each denominator into that LCD. So 2 goes into 10 how many times? 2 goes into 10 5 times. So if I do 5 times 1, this is just going to be 5, and then I still have to distribute that into the 3x minus 2. Moving on to the next part, 5 goes into 10 twice, so now I'm left with 2 times 2, so that's 4. So then I'm going to subtract this off, 4 times 2x minus 3. I'll worry about the distribution later. And then 5 goes into 10 twice, so it's 2 times 1. 2 times 1 is 2, and then this leaves me with x plus 1. So there is kind of the problem. So from here now we can go ahead and distribute. So let's do that. And one word of caution here, I would just recommend that you make sure that you have your signs right. So this should be minus 8x plus 12x. That's a really common error to not distribute the negative. So from here I can collect my like terms. So this is going to give me 7x plus 2 equals 2x plus 2. So now I'll subtract off the 2x and I'm left with 5x plus 2 equals 2. And then I'll subtract off the 2, so I get 5x equals 0. And it's totally fine to have a 0 on top, so I get x will equal 0, and that's my solution to this one. Okay, so let's clear some space and do another one. Okay, so here is the next problem. So I want you to try to do this all on your own now. I will give prompts one more time in case you want to just go step by step with me. So you know that you're going to have to find the LCD here first. So what I want you to do is determine what is the LCD and then set this up so that you multiply everything by the LCD and then cancel out the fractions. So let's just go forward a couple of steps here. Hit play when you're ready. So the LCD here is 8. So now I need to multiply each one of these by 8. So I guess I'll just kind of write this over to the side here like this, and so then I'll start canceling things out. So 4 goes into 8 2 times, so I need to take 3 times 2 in the front, so this will leave me with 6 times 2x minus 1. Okay, so moving on to the next one, 8 goes into 8 once, so I just take 5 times 1, so this will be plus 5 times 2 minus 4x. And then this last one, so 4 goes into 8 twice, so I multiply 1 times 2. This will ultimately equal a 2 in the front, and then I still have to distribute this. So from here, now let's go ahead and distribute. So if you got to this point, I would recommend maybe just pushing ahead now and trying to get to the final answer, and I'll meet you there. So first I need to distribute, so let me do that. And now I need to collect my like terms. So this is going to give me negative 8x plus 4 equals 4 minus 8x, and you might already notice this is infinite solution, but if I went forward with this I'd get plus 8x, so I'd see I have 4 equals 4, and so this ends up becoming infinite solutions. Okay, so I'm going to do one more of these if you'd like to see another one. So let me set that up. Okay, so here's the last problem. So for this one, I'm just going to leave this one totally up to you guys. So you can go ahead and find the LCD and do everything kind of with that. And just hit play whenever you're ready to see the solution. So to begin, so my LCD in this one is actually just 12. And so I need to multiply everything by 12. So I'll just go ahead and write that out over here. And I'll make my cancellations. So 2 goes into 12 6 times, so I need to really take 1 times 6, so this will end up being 6 and then 2x plus 3. Then for this next one, 3 goes into 12 4 times, so I take 1 times 4, so this will be minus 4 times 2x minus 1. And then for this last part, 4 goes into 12 3 times, and so then this will give me 3 times x plus 7. So from here I can distribute, so I'll go ahead and do that. And now I can collect my like terms. And now I can go ahead and subtract the 3x from each side. And then I can subtract the 22 from each side. So ultimately I get x equals negative 1, and that'll be my solution. So, you know what, I will actually just show another one, so I want to make sure that there are plenty of these examples in case you want to try them. So if you feel good here, thanks for watching. I'll see you in another video. If you want to see another one, hold tight. I'll set up another one for you. Okay, and so I have another one of these here for you. So once again, if you want to give this a go, you can just hit pause and hit play when you're ready, and I'll show you the whole solution. So for this one, my LCD is 4, so I need to multiply everything by 4. So got that, and now let's start making our cancellations. So 4 goes into 4 once, and so if I just take 3 times 1, this becomes 3 times 4x plus 5. And then 2 goes into 4 twice, so if I take 1 times 2, that will be plus 2 times 2 minus 3x. And then for this last one, so cross out those 4's, so 4 goes into 4 once. 3 times 1 is 3, and then that's 2x plus 1. So now I can go ahead and distribute, so I'll show you that. And now I can collect my like terms. Oops, I just recognized that I made a mistake, sorry. This should be not 12x, this should be 6x. There we go. Okay, so now I can collect my like terms. Sorry, my bad. And now if I subtract the 6x from each side, I'm left with 19 equals 3, and so we should know what that means. That means no solution. Okay, so I will do one last one just in case you want even more examples. So like I said, I didn't want to leave anybody hanging. I know sometimes these fractions can be really, really tough. So let me set up one more for you guys. Okay, and so now this is kind of almost a hybrid of the two techniques, huh? So once again, you can hit pause and then hit play when you're ready to see the solution. So here my LCD is going to be 15, so I'm going to go ahead and multiply each part by 15. And now I can do my cancellations. So 5 goes into 15 3 times, and 1 times 3 is 3, so this is 3 times 2x plus 1. Then for the next one, 3 goes into 15 5 times, so 1 times 5 is going to give me 5, and that's actually it. And then 5 goes into 15 3 times, so 2 times 3 is going to give me 6. So here's what I'm left with. So now I can distribute. That should be 6x plus 3 plus 5, so then this is 6x plus 8 equals 6. Subtract the 8 from each side, I get 6x equals negative 2. Divide each side by 6, and you get x equals negative 1/3. Okay, so that is it for all of the examples that I have on just fractions. So hopefully you feel pretty good on that, and I will see you guys in the next video. Thanks for watching.